Hello everyone and welcome back at CodingBulls. Today we will continue a competitive programming series and we will take a look into two different types of problems. One of them will be a greedy problem and the other one will be a two-pointer problem. I already selected these problems. Let's go ahead and open up CodingBulls. And this is one of our problems. This will be a greedy problem. So let's go ahead and read the problem statement. And by the way, if you remember from our previous video, you can search for problems in CodingBulls and the problem set, take your desired difficulty, add any text that you would like to practice, and you can apply. So if you would like to take a look at more greedy problems, you can check out any other of these problems. I will explain the solution for this particular problem in this video. So let's take a look at the problem. We are given an array of positive integers, and we can see that we index from 1 to n. It will be imported later in the problem statement. And we need to make the product of all numbers in the array divisible by 2 to the power of n. And we can select any index and replace the value of it by multiplying it by I, where I is the index. And we can't apply the same operation to the same place, so we need to choose another one of the different i's. And we need to find the smallest number of operations we need to make all the elements in the array divisible by 2 to the power of n. And as we can see in the input, we will have the number of test cases first, and then we will have a test case which will contain the n and the array A with n numbers. And we can see that the sum of n doesn't exceed 2 to the power of 2 times 10 to the power of 5. And for each test case, we just need to output how many operations we need to do. We don't need to output the operation itself. And if we can't make it, then we need to output negative. So let's go ahead and open the code box and start working on the solution. First thing I want to show you how you can easily deal with multiple test cases. So I usually have a TE variable, which I initialize as 1. Then I will take it from the input. Of course, if you take it from the input, it doesn't matter what you initialize it. I will show you in a moment why this is a good trick. And by TE minus minus, this will be a loop that repeats TE times. But you need to be careful because it only works if TE was not negative. Because if it's negative, then you will detect the value and it will always be negative. And actually, this will only return false if this returns 0. So, and here we can either write the code here again, or we can create a function and usually called solve, and you will have a solve function here. So if you have a problem with multiple test cases, this will be always your main function like this, and your new main function will be the solve. So every time you have a new test case, you will start executing from here. So you can have this main function here and treat this solve as a new main function. You can also have a return value like in the main, but I usually like to have void here. What you need to be careful about is if you have global variables, they won't reset after the solve function. So you need to make sure that they have the good default values, or you won't need to use it. So we have the solve function here, and now we don't have to worry about these test cases. And why this is a good thing is that if you have only one test case, you can just comment out this line of code. And now we will repeat this solve function one time. So that's why I like to initialize it here as 1, because if I start doing a contest and I want to be fast, then I can just remove this one line of code, and then I can just write my code here. So that's why I usually look like this. So this is actually a good example on how to prepare to a contest. If you will start doing CodingBulls and you start your first contest, time matters, so you don't want to waste time. So you can prepare codes before the contest. Of course, you don't know what the problems will be, but you can write codes to prepare. In a later video, we will look on my prepared CPP file, which contains lots of classes that make me do the problems faster. But for now, this is a very simple line of code. And inside of the solve function, now we can take the input So we will have an n. You can type the initialization first, then take from the input, or you can just take from the input everything and don't forget to initialize after. So then we will take from the input. Now you need to make a decision what type of container do you want to use. Do you want to use a vector? Do you want to use an array? And we will index from 1 and the index matters. So my advice is, if you dynamically need to change it, or you need to sort it, or you need to do any of these operations with it, a vector is usually better. If you have a fixed size and you don't really want to do any of these operations, then you can just simply have an array instead. In this case, I think I will use a simple array, just so I don't have to worry about the index, because in the statement we index from 1, but you can use a vector as well, of course. Most of the times I would say it's better to use a vector. You can do more things, and if you don't have a clear solution in your head right away, then you can use a vector, because you can do anything with a vector that you can do with an array, but not the other way around. So it's better to use a vector if you don't know that what you will do. But for me, I have a very good plan in my head, and I will actually go ahead and index from 1 for my array again, because in this particular problem we will need to use the index as well. And outside I will have a long array. The reason I will have a long is that I don't know yet if I will fit in the integer limit. It's most of the time it's worth it to use long. It won't affect your memory limit by a lot, and it's just better if you don't want to worry about going through of the integer limit. So I will have the long a with the size, and you can also have this constant n. You can also have this line of code before you start working, and then you just need to replace the value. If I remember correctly, it was 2 to the power of 2 times power of the 5, and I will add 1. Don't forget to add 1 if you index from 1. Yeah, it was that. And now we have the input. And now let's think about what happens when you solve the problem. So your array will be the same, so it won't be reset every time you run, but you will update the values from 1 to n and update the value of n. So it's possible that in the first test case n was 10, and in the second test case it was 5. So you will have the values from 6 to 10 in the array already, but you will have this n value here saying you that the size is only 5. So you don't need to worry about this right now. You just need to make sure to not go outside of the boundaries, because there will be a bunch of trash data there that you don't want to use. So now let's solve the problem. So we want it to be divisible by 2 to the power of n. So we want the product. Let's say that p is the product. Should be something multiplied by 2 to the power of n. K is an integer. Now we take one more look that 0 is not allowed here in the array, which is important. So that means that we want it to be a multiple of 2 to the power of n, and k can be anything. So lots of the times a greedy program just requires one idea. In this case it will be a mathematical idea. This means that the product p needs to be divisible by 2 n times at least. What I mean about this is every number has a prime factor. Prime factor is something, let's say that you have a number, let's call it x, and you will have prime 1 to the power of, let's say, y1 times prime 2 to the power of y2, and so on. So these numbers will be all prime, and these will be just positive integers. So here we want the power of 2 to be at least n, and all the other doesn't matter because we don't care how many times we can divide this. We just care about the 2 power of n. So any other primes, 3, 5, 7, it doesn't matter. We just care about the 2. So but we want to know how many times these numbers are divisible by 2. So I will have a count here, which I enter as 0, and I will count how many times these numbers are divisible by 0. So the way we can do it is by ai is divisible by 2, then we will say that the count should grow by 1, and we will divide it by 2. Now if you want to obtain the original value of ai in the array, because maybe in the future you will need it, then you should do is have any variable here, and now we will use this value here. So this way we still have the original value of ai in the array, and we just modify this value which we want to use in the future. So now we counted how many times it's divisible by 2. So if this count is at least n, because we want it to be divisible by 2 n times, then we will output 0. So because you need to output each test case in new line, you have two options here. You can either output a new line inside of the main function after every solve, or you can output a new line every time after you output a solution. It's up to you which you want to prefer. I usually output a new line anyway, so I will just use it like this. Otherwise, we will just try to make this count at least n. So what we will do is, obviously we want to go back to the program statement, and here we can multiply any number by its index. So because we don't have 0 value, it doesn't matter which number we multiply. We just want because we want to get the product, and for the product it doesn't matter which part of it you multiply it, we multiply the whole value anyway. So every time we multiply, we want to start from the largest power of 2 and go to the lowest. So we need to take a look which number is how many times is can be multiplied by 2, divided by 2. So what we will do is, here in the for loop, when we go from 1 to n, we will push, we have a vector of integers, and we will have a value which is I, and while this value is even, we will have another count, and we will divide it by 2. We have the other count here, and in the end we will push back the vector. So what this does is, for every I, so the indexes, that this is the indexes that we can multiply with. These are our options, and we can use all of them only once. So we will push back, instead of this index, we push back how many times it's divisible by 2. Because we don't care which index we multiply, we just want to know how many times it will affect the division by 2. Of course, if you want, we can have a pair of int integer, and we can push back the index itself too. Because we want to sort this easily, make sure that the first value is always what it will sort based on. So we want this to be the first value, how many times it's divisible by 2, and then you can move the index. Of course, in this program statement, we didn't even need the index because we just care about the number of times it's divisible. So we will sort this way. And if you remember our previous video from the vanilla C++ tutorial videos, if you want to put the highest value first, then you need to use the begin, or you can, and if you use begin, you need to use end, or you can use begin and end, but you need to swap the values in the end. So reverse with the reverse function. We don't begin, we don't end here as well, but we can use the begin and end to sort it like this. And now we have the highest value first. So now we will go through the array and here we will add to the count the number of times we are currently divisible by 2, the vi dot first, because this is the first value that represents how many times it's divisible, and if we multiply two numbers, their power will be added up. So now we added it, and we check if count is at least m. Then we have the answer, which will be in this loop. So we used all the multiplication from 0 to I inside of this for loop. So the answer will be I as 1. And we move to new line. And don't forget to return. So this return returns from this sort function. So now we checked how many times we need to multiply it and then output it. So our greedy solution is simply go from the highest to lowest, and we sort based on the number of times the number is divisible by 2. So now if we go ahead, be done it, and take the input from here, I usually like to swap the code forces, then copy the code while my code is compiling. So if it takes a few seconds, then you can just copy the code. And of course I forgot to initialize n. Now we can copy and paste. And what's interesting is when you have these multiple test cases, then when you copy the code, so we copied the 6, the number of test cases, then we copied 1 and 2. And then the next test case would be 2 and 3, 2. But before that, it will output the solution for that problem. Now we can see that we forgot to return here as well. So after you have the solution to return, so that's why it's good to run it. Sorry. So we will copy it. So when we have the 6, 1, 2, so I go ahead and check here. We outputted 0, which is the correct answer. Then we have 2, 3, 2. Then we outputted 1, which is the correct answer. And this, and we outputted 1, and then and one more thing that we forgot, if we can't solve the problem, then we need to output -1. So we have the answers 0, 1, 1, -1, 2, and 1. So you might notice that it's a bit hard to see what our answer is here, because it's merged with the input numbers. So what you can do to solve this is use the console error. So this is a really good trick, because even if you don't remove this line, your solution will be correct. Because most competitive programming, including CodingBulls, everything that you write to the errors file will be considered differently and won't affect your output stream. But when you run it locally, it will go to the same place and you will see it. So if you run it from CodeBulls, you will see these outputs. But when you upload it, it won't affect your solution. Of course, if you upload way too much thing, it will show your solution. But just outputting these some characters, it won't affect anything. Just don't output too much end lines which flashes the output, or too much information. So now if we build and run it, the difference will be after we copy the input, and I don't think it's copied, so maybe I'll do it again. Paste it. So as you can see, every time before we start a new test case, we will output this exclamation mark. So we can see which test cases is which. So we can see that everything that we outputted last is maybe our solution, like here. Or if you want the exclamation mark to be before your output, then you can take the input, and when you are done with the input, then you can output the exclamation mark. Or another solution is to write the solution to file. I feel like it's a bit slower to deal with files during competitive programming, so I prefer to actually get it at the console string. So to copy it, and now we have the exclamation mark before each of our answers. So 0, 1, 1, -1, 2, 1. So this is easier to see this way. If you want, you can do this. Of course, if you see it even without this, then you don't have to worry about it. It's completely optional, it's up to you. Anyway, so we are done with the problem. So let's go ahead and submit it. So the important thing, by the way, and because it's accepted, I took a look on the problem statement and see if 0 is not allowed. Is because if 0 was allowed, we would have an infinite loop here. You can divide 0 by 2 any number of times, and you will still get the same values. So it won't be good. And one more thing important to look is what's the maximum number of times you can make these operations, because every time you have a nested for loop or a while loop in a for loop, you need to be especially worry about it. So this is the number of times this value can be divided by 2. And the number of times it can be divided is, of course, infinite if it's 0, but for all other cases it will be the maximum value, it will be the logarithm of it. So n times log n in this case, or n times log maximum value. But even the log of 10 to the power of 9 is really small, so it's fine. It's inside our time limit, so we can do it. Hopefully you enjoyed this problem, and now we will take a look on 2 pointers. And we have this problem for a 2 pointer. So we are coach at our university, there are students, and we have the skill levels of it, and this long story short, we want to select the most of them, but their skill differences can't be more than 5 for any 2 of them. And now we have the array, and now we have the values. So, and we have only one test case here. So normally you want to create more files before you start a contest. So you would have this file and another file open as many problems as there are. And in this case, I will just use this file and delete everything in the solve function. And you can start here. So now, because there are only one test case, I will just remove this input part. So now we will repeat this process one time. So we will start actually in the solve function. And now this will act like another main function. So we have first the n, and then we can repeat n times, and then take the value, and I will use a vector this time. The reason for this is we will want to sort the values. So we will have none, and once again, I don't know if I will fit in the long loop minutes or not, so I will use this, and you can use long loop here as well, or maybe I will use long loop to n as well. So it's okay to use long loop everywhere, it doesn't affect much. So first thing first, if you don't have anything that the order matters or order of the input matters, you can just go ahead and sort the solution, sort the input. Doesn't hurt to be sorted. And now we have the skill levels in sorted order. So the way the 2 pointers work is you will have 2 pointers, obviously. I will call them small and big. Small will be 0 and big will be 0 as well again. So now we will have a while loop, and inside of the while loop, a good trick, if you want to have a while loop, do something while some condition is true, and you don't know the condition yet because maybe until the small is not reached the value or the big, then you can just leave this empty for now, or you can say while true or while 1, and you can come back to this later. Or you can break out of this is an infinite loop, by true or by 1. Either way, 1 is as a boolean considered true. So by 1 means that we will run forever this loop, or we can break out inside of the loop if that's more comfortable for you. But you need to make sure that you are not inside of an infinite loop. So the way we do this is check if the value, big value, is the small value, and the difference between them is less or equal than 5. Because if they are currently, then this is a good solution. So this will be the smallest index that we take into the team, and this will be the largest index. Of course, we want to have an interval of players, programmers I think in this case, don't remember, sorry. Anyway, so you want everyone in this interval inside of the team, because if you have a member which index in a sorted order is small and another member which is big, that means that you can take everyone between them, because the maximum difference won't change. So the optimal solution will have a small and a big index, and you will take everyone from there. So we will go through the small index and the big index as we can. and this will be the 2-pointer trick, so we can do it in time, because if you check the problem statement, n is 2 times 10 to the power of 10, meaning that we can't have a solution which runs n times n. So we need a linear or linear times logarithm or something like this. This will be actually linear, so time complexity. So we will start from the 0, 0, meaning that we only take the first student in. And now, if big minus small, the difference is at most 5. Then that means, and by the way, if you are not sure if you sorted it from the small value or the big value, you can, or you are not sure which one is the right, you can just type absolute value to be sure. Of course, the big will be the bigger one, but if you want, you can just type it. Maybe you don't want to think it over in the contest, so you can have the absolute value here. So if it's most 5, that means that we are good, and this is a good team. And we will also have here, and I will check the problem statement if we need to output the team itself or just the number of players. We just need to output the number of players. So we will have an answer here. This is the most people that we can have in the team. So we will update the answer to maximum of answer and big minus small plus 1. So this is the number of people in this range, because we have big minus small plus 1 in the range. And this is the odd value, so we will just take the maximum of it. And what we will do here is, because this was correct, next time we will check what happens if big is larger. Otherwise, if this wasn't true, that means that the big was bigger by at least 6, meaning that we are in a bad range. So we will need to shorten the range. But the way we go through all the ranges is we start from 0, 0. We have a fixed small value first, and we go as long as we can, so we will do this while loop, this part of the while loop of this if statement inside here. So we will increase this big value as long as it's possible, so as long as the difference doesn't exceed 5. So we have the small value fixed at 0 first. Then we will increase until we can, and we will save the value. And then we will, let's say that the big value will be 5. Then we will increase the small value by 1, and then we will go in the big value as long as we can. Let's say that we can't go anywhere, we are still at 5. Then we will increase the small value to 2, and then we will go in the big value as long as we can, let's say to 10. And that's the way we will do it. And because every time we will either increase the small value or the big value, that means that this loop will run maximum n times 2 times. So the double of n, because we increase the big by n and we increase the small by n maximum. And that will be inside of our template. And the reason this is good is because, let's say that we have a range from A, or let's say L to R, and if this is a good range, that means that starting anywhere after L, so L plus 1, this will be correct as well, a good range. If this is good, then this will be good too, and L plus 2 as well, starting from L plus 2, L plus 3, and so on. So if for the given problem this condition is true, you can see that if this range is good, then this range is good as well. Of course, from this statement we can see that all of the, so because if this is true, then we can apply it as many times as we want. So if we put L plus 1 here, then L plus 2 may be true. So we will have all the values here as true. So if if we can see that this is true, then we can use this 2-pointer tactic. In our problem, of course, if each of the paths between here is at least 5, then each of these paths will be here, the difference will be at least 5 as well, because we just have a sub-array here of this. Meaning that if this was correct, then this will be correct. So if we are at small and big, then after we are not good anymore, so if we can't increase big, that means that we will increase small until we get the first time that we are good. So that way we will always get the correct solution. So here we will simply increase the small value. So we increase the big value as long as we are good, and if we are not good anymore, then we will increase the small value as long as we are not good. And when we are good again, then we will increase the big value as much as we will be good. Therefore, we will go through all of the solutions which is correct, and we can take the maximum out. So here, this in the value will be that the big is less than v dot size. So we are inside of this v array, and actually small should be less than v dot size as well. Technically this condition doesn't matter because small will always be at most big. So you can take this out if you want, or you can leave it here. It's up to you. Because of this problem, this will work in a way that this condition is true, and on if this condition isn't true anymore, then this won't be true anyway. So here we will save the answer, and in the end we will output the answer, and we are done with the problem. So this is the 2-pointer tactic. We can go and read under it. And when you have multiple test cases, like in the examples, then you can either just paste few of them or one of them, or it's up to you. Depends how confident are you in your solution and how important it is for you to submit it a bit faster. So it's usually not a big deal if you submit it a few seconds later, but if you want to make sure, you can copy these values. The trick I use is that when there are more examples, is that I usually copy them faster and check the values from the second, third examples, not the first one. The reason for this is CodingBulls actually doesn't deduct points if your answer is wrong on the first test case. So I just say those few seconds, and if it's a wrong answer for some reason on the test case one, then I will get that verdict and I don't lose any points. Anyway, let's go ahead and submit it. And we can see if it's correct or not. Thank you. And it's accepted, so it's correct. Hopefully you enjoyed today's video. If you did, make sure to like and subscribe, and see you the next time with more competitive programming problems.